So I had this idea, and I actually got this. It's a paint. It's a paint marker. Supposed to be. Let's see how it works. Okay, works pretty good. So in base 120, the number system I use, this is 120. Right, and I made a couple videos explaining, there's digits for the ones, and then there's digits for the 10s or the 12s, depending on what base you're using. And you could possibly, you could basically write any digit down, as two digits. So basically, for example, the number 919. What you would write down is you would put a 7 here, because yes, believe it or not, it starts with 7. You go 7, then you got 79. So that is 7 followed by 79, 7 sets of 120, and 79 digits, 79 units, maybe I should say units. But I had this idea that, okay, so basically 14,400 could be written like this, right? But I had an idea, actually, and tell me if this is a good idea, if you're interested in this. A shortcut to writing this could be this. The 0, it represents how many zeros there are, right? Another example would be, what is that? That is 14,400 plus 120 plus 1. It's 111, right? And I think that's an interesting thought. So, I mean, basically, let's do a little multiplication here. Let's do, for example, 1, 0, 0 times 3, 0, 0. So you got 0 times 0, which equals 0. 0 times 0 plus 0 times 0 equals 0. Right? So you got two zeros. And then you got 1 times 0, which equals 0, plus 3 times 0, which equals 0, times 0 plus 0 times 0, which equals 0. So there's 3 zeros, right? Then you can do 0 times 1 and 0 times 3, which equals another 0. And then you could do 0 times 1, which equals 3. So essentially what we've done is we've taken both of these zeros and we put it here, but instead of writing this, what we could write is this. And what this is, it's basically 120 times 3 to the 4th power. And so this is just an interesting thing that I came up with. What's 144,000? 144,000 would be you know, the number in the Bible. It's cooler in a way with this, but basically that's what it would be. 144,000. 1, 2, right? You got 2 dots that follow it, right? So that's just an idea I had for a shortcut in writing these numbers. And it's actually pretty interesting, I think. You know, if you was going to, I don't think it ought to be over 4 dots, but if you, but basically you got 3 times 10, and that would be 30. I still haven't completely, you know, agreed with myself on what 30 should really look like, but let's just do it like this. Let's do 30. And then, you know, how many dots are there? And there you go. And what that basically is 30 times 120 to the 6th power. That is very huge. That might not look like a big number at all, but that is, you know, just to give you an idea of just how big a number like, you know, there's a difference between 144,000, because let me show you the difference. Let's just say we was going to write 1, 4, 4, and we was going to write 3 zeros after that. This is equivalent to 1,720 1,720,000 in ordinary digits. Okay, that's what this is. Times this number right here, which in base 120 is essentially 14,400. Okay, that's just to give you an idea. And if it was 40, it wouldn't be this, it'd be this, or something similar to that, right? So this is a big ass number. Just to give you, just to clarify just how damn big that number is, this is what it would be in base 10. And you would do, you know, 0 times 0, which you can see, it's probably going to have all the zeros there. You know, you got 0 times 0, which is 0. Then you got 0 times 0 plus 0 times 0, which is 0. Then you got 0 times 0 plus 4 times 0 plus 0 times 0, which is 0. Right? And then you get to the point where there's this many digits. So you would do, right, you do 2 times 0, which is 0. Then you do 4 times 0, which is 0. 4 times 0, which is 0. 0 plus 0, which is 0. And there you go, that's another 0. And then you would get to where there's, you know, this many. Right, and you would just keep going. 8 times 0, 0. 1 times 0, 0. 2 times 0, 0. 4 times 0, 0. 4 times 0, 0. So 0. And then you would do, well, there's this many. Right. So essentially we'll do 0 times the space, which is 0, 7 times 0, which is 0. You know, basically just all zeros. All 5 of the zeros. except at some point there would be an extra one. Let's see here, 0. Okay, that times 0 is 0. This times 0 is obviously 0 because it's 0. This is 0. Then we got 0, 0. I think that's 0 again. As a matter of fact, in order to make it less confusing, you probably just do the obvious. No, and we was doing it wrong anyway. That's supposed to be a 2. That's supposed to be an 8. And you're going to multiply that by 144. So 8 times 4 is 24. Then you got 8 plus 2, which is 10. Plus 24, which is 34. 7 times 4 is 28. You got to add 3, 8, 10, 11, so that's 31. Then you do you got to add 8, which is 39. Then you would add you essentially add another 8, which that's basically going to be 47. So you should bring a 7 down, I think. You know, it's kind of hard to do in your head. 47. You do 4. You add 4, so that's 8. 8 times 0 is 0. Then you do 2 times 1, you add that to 8, that's 10. Then you do 4 times 28. And so that's 38, I think. I think that's 38. And then, you know, there's not enough space here, so you bring us down. And if this is done right, I don't know if I'm doing it right, but you got 3 plus 4 times 1, which is 7. Then you got 2 times the emptiness, and then you got to add 7. 2, 7, so that's 14. Carry the 1. And then you do 7 times the emptiness, which is 0, and then you do 1 times 1, which is 1. And I think if you add that up right, you would get a very, very big number. Very big number. This is what 144,000 would be in base 120. So you'd have something like 148 trillion, 744 million, 148. Wait, no, it would be billion. Would be billion, right? Let's see. So that's thousands, millions. Let's see, hundreds. Right, it gets in here, it gets thousands, millions, billions. 148,744,000. No, 744 million. 148,744,000,000. It's been a little while since I did math, but there you go.